All right, I trust you did well on that quiz. Let's go ahead and pick up in your notes where we left off last time. Also, if you would have your books open to page 20, we'll be there in just a moment. At the end of the lesson yesterday, we were looking at these special triangles. And we were looking at the special angles, the 45-degree angle, the 30-degree and 60-degree angles. And of course, we replaced all of the x's with 1s. Now, instead of 2 times 1, of course, we just say 2, square root of 3, square root of 2, but the plain old x's are replaced with 1s. And we said we can find exact values of our special angles using those 2 special triangles. We've used them before. But there was a third special triangle that I introduced yesterday. Chris, were you able to watch the lesson?
I did watch that. I don't remember the triangle.
Okay, it was sort of a triangle. It was a non-triangle, but we made it look like a triangle, Quentin.
9, 9, 0 triangle.
Yeah, I call it the 0, 90, 90 triangle. And just so we can kind of keep them all together over here, the 0, 90 triangle, basically we tried to make it as little and flat as possible while still having just enough room to do some writing in here. So we said that this angle, well, you can't really draw it 0 degrees, but we could say it's approaching 0 degrees. And if this angle is approaching 0 degrees, then this angle must be approaching class 90 degrees. But if this angle is approaching 0 degrees, then this opposite side is approaching what length? 0. And if this really became 0 degrees, we would have nothingness over here. At which point these two lines would be equal. Right on top of each other, coinciding, right? And therefore we could call them whatever we want as long as it matches. I'm lazy, I'll call them both 1. And so we could find the sine, cosine, tangent, and reciprocals of 0 using adjacent, opposite, hypotenuse. We can find sine, cosine, tangent of 90 using hypotenuse, adjacent, and opposite, right? The key is you will occasionally get 0 over a 1. Well, what is 0 over 1, class?
1.
0. 0 divided by anything is 0, right? You will occasionally get a 1 over another 1, and at that point, of course, we know 1 over 1 is 1. And you'll also get a 1 over the 0 a couple times. And when we get that, we know that anything over 0 is undefined. So remember, you can't have a 0 denominator. In fact, remember in algebra we said, well, if this would make the denominator 0, we have to say that you can't have that because you can't have a 0 denominator. It's infinite in a sense. How many times can 0 go into 1? How many times can nothing fit into a 1? Infinite number of times. But because infinity is undefined, we would call that undefined. So, on page 20, using these triangles, not using the chart from yesterday now, I want you to do numbers 1 through 29, the odd, on page 20. I want you to do 1 through 29, the odd, there on page 20. Don't use the chart. Base it off the triangles. If you want to draw the triangles on your own paper, by the way, so that way you're not having to keep looking up, that's fine as well.
You show how to do number 3.
What is number 3?
Sin 45.
Sine?
Sine,
Sine of 45 degrees? Well, you look at a 45-degree angle. And sine's whatever what?
Opposite over hypotenuse.
Opposite over hypotenuse. But, again, the x's cancel. So technically this is a 1, and a 1 squared root of 2 are just square root of 2. So you make the ratio and you reduce it down. about a minute and a half longer to see if you can get all 15 of these. We are going to use these a lot. So the goal in doing all of these is to get very, very quick at recognizing and very, very accurate at recognizing these values. Don't laugh. That was you just a few years ago. I mean, back when you were a 3.
More like yesterday.
I was actually quiet as a child.
Quentin, what number are you on?
25.
25. I guess I made it most of the way through. Jamie?
21.
21. Okay, got a little further to go.
I'm done.
Done? Good.
21.
21. Okay, so I had a little ways to go. Let's see how we were doing on the ones we got done. Number 1, what is the sine of 0 degrees, Ethan?
0.
0. The sine of 45 degrees, Chris?
45 times square root of 2 over 2.
Where did you get 45? Just square root of 2 over 2.
Why is the 40?
The sine of 45 degrees. Okay, so let me help you with this. The sine of 45 degrees is equal to the square root of 2 over 2. Sine is always opposite over hypotenuse. For a 45 degree angle, the opposite is 1. The hypotenuse is square root of 2. So it's 1 over square root of 2. That's what it equals. It is equal to that. Which is why, by the way, it would be wrong to say sine equals 45 degrees. No, sine of 45 degrees is something. Does that make sense? All right, so yeah, that's all we would say. It's just square root of 2 over 2 is the answer to the sine of 45 degrees. So the sine of 90 degrees, Jamie?
1.
1. The cosine of 30 degrees, Quentin? Square root of 3 over 2. The cosine of 60 degrees, Ethan?
Square root of 3 over 2.
Help him, Chris.
I didn't get it right because I did all of them the same way I did the 45.
Okay, so what should it be then, Chris? The cosine of 60 should be what over what?
Cosine of 60 should be 1 over square root of 2.
60? Where's the 60 degree
Oh,
angle?
it's on the 30, 60, 90 triangle.
Right.
So it should be square root of 3 over 2.
What's cosine? What over what?
Cosine is adjacent over hypotenuse.
Right, we can't forget. It has to be automatic.
1 over 2.
1 over 2. Does that make sense now, Ethan?
Yeah, that makes the 30 degree.
Right, the 60 is the one with the double line, the
Yeah.
bigger angle. The 30 is the little slivery angle. Okay, so got it. And that's why we're practicing, right? Is to make us get these straight. Because, again, these are answers for now, but in 2 or 3 more days, these are a means of getting answers. And you screw this up, you have no hope of getting correct answers, right? So we've got to get these mastered. And that's what we're working on. Number 11, let's go back to Ethan, the tangent of 0 degrees.
0.
0. Number 13, what should we get for the tangent of 45 degrees, Chris?
So that should be 45, 1 over 1.
1 over 1, which is just 1. There we go. We're getting the hang of it. Again, you weren't here for the practice yesterday, so even though you watched it, it's different when you're doing
It's
it.
hard for me to watch things and understand things.
All right, let's see. Jamie, number 15, the tangent of 90 degrees.
1.
2 square root of 3 over 3.
For 90 degrees? Tangent of 90? Remember, you can't look at this 90, class, and you can't look at this 90. You have to look at the acute angle. This 90, the not really 90, 90, right? And we're thinking, what was it, tangent? Tangent of 90? What's tangent? What over what, class? Opposite over adjacent. What's the opposite?
1.
What's the adjacent?
1. Or 0.
0. So 1 over 0, which is undefined. Number 17, let's go back to Quentin. 2 is correct, or 2 over 1. Number 19, Ethan.
2 times square root of 3 over 3.
There we go, 2 square root of 3 over 3. What should we get for number 21, Chris?
It should be 1 or 0 over 1.
What is secant, the reciprocal of?
Secant is the reciprocal of cosine.
Which is what over what?
Adjacent over hypotenuse.
So therefore secant is?
Oh, so it's 1 over 0.
Secant is 1 over, or hypotenuse over adjacent, correct?
Right.
So for a 0 degree angle, what's the hypotenuse?
1.
1. What's the adjacent?
1.
1. So it should be 1 over 1, which is 1. Does that make sense? All right. Number 23, Jamie. What should we get? Secant of 45 degrees. Secant's what over what?
Adjacent or hypotenuse?
Well, flip it.
Hypotenuse.
Hypotenuse over adjacent. So for this 45 degrees.
Square root of 2 over 1?
Square root of 2 over 1, or just square root of 2. There we go. Number 25, Quentin. Secant's what over what? Hypotenuse over adjacent. So we're looking at the 90, but again, this 90, hypotenuse over adjacent? 1 over 0, which is undefined, should be our answer. Number 27, Ethan, I know you didn't get to it earlier, but what would we get for the cotangent of 30? Take just a moment.
Square root of 3.
Good, the square root of 3 over 1, or it's just square root of 3. For the 30, which is the top little angle, adjacent over opposite, square root of 3 over 1, or square root of 3. And then number 29, the cotangent of 60 degrees, Chris.
2.
We're looking at the 60, which is right here, correct?
Right.
And it's cotangent, which is what over what?
Cotangent. So hypotenuse over.
Well, cotangent is the reciprocal of tangent, right? Tangent's what over what? So
Adjacent over hypotenuse.
toa.
Oh, opposite over hypotenuse.
Sokatoa.
Toa is opposite over hypotenuse. So it would be hypotenuse over. Oh, opposite over adjacent.
Opposite over adjacent. So, toa, opposite over adjacent. So we're going to flip it for the cotangent, make it adjacent over opposite. So for 60, adjacent
X. So 1
over opposite,
which is square root of 3. So 1 over square root of 3.
1 over square root of 3, which rationalizes to
Square root of 3 over 3.
square root of 3 over 3. All right, so of the ones you did, anyone miss 2 or fewer? Anyone miss 2 or fewer? Okay, so Quentin, you feel like you've got a good handle on this. Jamie, you feel like you've got a good handle on it?
2 or fewer.
Really? Okay, good. Okay, so Chris, you're the one who kind of, and again, understandably so, you weren't here yesterday. Do we feel like we understand it better as a result of this? Do we feel like we understand exactly what we're doing with these now? All right, I'm going to give you some more practice with your homework this evening, but for now, get your calculators out, and we're going to practice using your calculator to do something you wish you would have known last year. But I'm a rat, so I didn't teach it to you. I'm a rat, and I need all of you to be rats and not teach anyone else how to do this.
Fine.
All right, so this is you have to wait till you're in pre-cal to learn this. And you remember in geometry class, if we had like a 15-degree, 30-minute, 45-second angle,
Yeah.
and we wanted to make this decimal degrees, we would take the 45, we say, well, that's 45 60ths of a minute, right? Plus the 30 minutes gives me 30 and 45 60ths minutes. And of course, we still have the 15 degrees. And we said, well, 45 60ths is 0.75, so this is really 15 degrees, 30.75 minutes. And well, this is really 30.75 60ths of a degree, along with these 15 degrees. And then we turn this into a decimal and all that. You remember all that? Yeah. Dividing by 60 to convert seconds to minutes and then minutes to degrees. Your calculator can do all of that really easily. I want you to look at your calculator. And again, if you're using the TI-30XA, this is great for you. Unfortunately, for the camera, nobody in here is anything different. So I can't show you how to do it on a different calculator. I suppose if you're watching and you have a different calculator, I can work with you through video chat and show you how to do that, or try to tell you how to do that. Or you can just get a TI-30XA for $10-ish and enjoy what we're doing here. I want you to look down at your plus sign and your equal sign. You see the second function, those little green letters, or Chris, gold letters on yours, DMS to DD, DD to DMS? That means degrees, minutes, seconds into decimal degrees, and decimal degrees into degrees, minutes, seconds. You can convert back and forth. So let's take this same thing here, and let's enter it degrees, minutes, seconds to DD. How you're actually going to enter it on the calculator is your degree symbol becomes a dot. 15 dot, and you're going to enter these digits just straight as they come. 3, 0, 4, 5. And then you're going to use the second function on the calculator to go from these degrees, minutes, seconds into decimal degrees. So 15.3045, second function, DMS to DD, and it gives you, now you knew this was going to be just barely bigger than half, right? 30 is half of a degree. It's going to be a tiny bit bigger than half a degree. It's not 15 and a half, but 15.5125 degrees. Make sense? So if I had 78 degrees, 14 minutes, what do you suppose I type on the calculator first class?
78.14.
78.14, and the second function, DMS to DD. And what is that?
78.23.
Good, 78.23 repeating degrees. Okay? Here's where it gets a little weirder. Suppose I had, 158 degrees, 3 minutes, 12 seconds. When we enter this, if you do 0.312, it's going to think the first two digits are your minutes. So here we'd have to do 158.0312. Does that make sense? And we get what decimal degrees?
158.05333333.
Right, so there's the equivalence from degrees, minutes, seconds to decimal degrees. What if we had, 120 degrees, 54 seconds? Well, what happened to the minutes?
You just put 0.
There weren't any, so we'll put
0,
00, so 120.0054. And of course, it's going to be just the tiniest bit of extra degree, 120.015 degrees. Okay, so barely any more degrees at all, right? 54 seconds is such a tiny part of an actual degree. Then what if we had 2 degrees, 2 minutes, 2 seconds? Yeah, 2.0202. And again, it's going to be just the tiniest fraction, a part of a degree there. So 2.03388. And then the 8 repeats at that point. So 2.0338 repeating. All right, do we see how to do that though? Isn't that so much quicker and easier?
I don't
Yes, but we make the geometry students suffer, so we don't teach this to them. Okay, no fair share in that. Now, if you happened to have degrees in a decimal form, and you wanted to see what it is in degrees, minutes, seconds, for instance, if you still have the 2.03388, blah, 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 if you do second function DD to DMS, notice how it shows up on the calculator. 2 degrees, 0.2 minutes, 0.2 seconds, and then there's 2 extra zeros as placeholders that could become fractions of even, or a decimal portion rather, of even a second. Okay? So, for instance, if we had, 13.58 degrees. Well, let's see what that is in degrees, minutes, seconds. It is exactly 13 degrees, 34 minutes, 48
So you can
seconds.
do the degree symbol, but we can't.
Yeah, I was about to say.
Yeah, you don't have, there's not a way to
That's
put
not
in the
fair.
degree symbol on this calculator, but it can put it out for you because, you're able to read it. Now, the TI-30XB or TI-30B or whatever it is, you put in the degrees, minutes, seconds, but it's actually quicker on this one. I'd rather have quicker than blah, 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 degrees, blah, 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 minutes, blah, 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 seconds. Enter. So this is the quicker, easier way to enter it anyway.
Are there huge scientific calculators that have every function you can think of?
Oh, yeah, but they cost lots of money and we don't care for
Over
those.
100? Over 100?
Oh, yeah. There's $150, $160 calculators. It's crazy. That's been on a laptop, but they don't make laptops that cheap. Oh, they do, but they're super old and used. Questions on how to do this? Because what we're going to practice in our next lesson is going to be finding trig functions of values where there may be degrees, minutes, seconds. Well, your calculator doesn't do that. You've got to put it into the decimal degrees first, then you can take sine, cosine, tangent, things of that nature. All right, your homework for this evening. for the weekend, actually. Homework for the weekend is to do page 20, numbers 2 through 30, the even. Do not use your chart. Okay? Page 20, numbers 20 through 30, the even. Do not use the chart to complete them. Use the triangles, and I would recommend drawing the triangles on your own paper. And we'll pick up with calculator in our next lesson on Monday. All right, have a wonderful weekend. You'll be dismissed when the bell rings. And I just realized I didn't catch any of this over here. So if you were trying to watch earlier, when we had those things, there's the numbers that I didn't show you because I forgot that the screen was over on the triangles. My bad.